Okay.
Hello, we are Sabrina, Eric, and Yichang. Our topic is credit risk modeling. The motive and objective for this project is to replicate the possibility of default analysis that has been performed by every large leading corporate and suggest the best model for prediction. The original dataset from Lending Club has approximately 46,000 samples with 18 features on personal borrowing information. We performed preprocessing and feature selection before training the model. When preprocessing, we observed that the dataset has a lot of features that contain information only available after loan is accepted. These features will significantly detriment our model and boost up our prediction accuracy by a lot. So we removed these features. Other than that, we also removed features that are uncorrelated with prediction, such as demographics information, and features with high number of missing values. We also transformed continuous features into interpretable int or flow and create dummy variables for all categorical features. And we dropped the features that are highly correlated with each other. And finally, we split the dataset into train and test sets and set the loan status as a target variable. We also applied PCA for dimensionality reduction. We used two components to explain a total of 98% of the variance.
Here are several models that we have chosen to implement. In this presentation, we'll mainly talk about decision tree, random forest, and Gaussian naive Bayes. Aiming to build the best model, we performed hyperparameter tuning on decision tree and random forest. For the decision tree, using grid search CV, we determined the best parameter to be 45, auto, 1, 9, and entropy. In addition to these parameters, we have tested two other parameters for random forest. There are N estimators and bootstrap. For both classifiers, we use threefold. But since there is a lot of parameters to try out for random forest, we use randomized search instead of grid search to save time in obtaining a relatively good set of parameters. Here are the results after using those parameters to build a tree and after train and predict. Note that the time taken for random forest is much longer than the decision tree here. And this is our ROC curve for those two models. And the AUC for random forest is also much higher than that of the decision tree.
The very last model we use in this project is the Gaussian naive Bayes model. On the same category, we have covered two different naive Bayes models in class, multinomial and Bernoulli. In general, NB model is a classification algorithm for binary and multi-class classification. A quick review on the formula on NB. So basically, next. So basically, we are calculating the probability for each hypothesis. One condition for the NB model is that we assume the features are conditionally independent to each other. Since my teammate has eliminated the highly correlated variable during the pre-processing, we can safely assume that the condition independence exists among the features. As we have previously introduced, our dataset is real-life values from the daily transaction of the lending corporates. So we can assume the normal distribution in those features. It is also worth mentioning that we didn't use the PCA dataset for this model. After PCA pre-processing, although each principal components are highly uncorrelated to each other, dataset is no longer normally distributed. So we decided to use the Gaussian NB model since it fits our dataset the most. Now let's take a look of our result. We have a very average AUC value from this model, which is 0.69, which is actually much better than the logistic model we used at the first place. The logistic model only has 0.59 in the AUC value. However, still it is this AUC value is not very outstanding. Now, this is our confusion matrix. For this matrix, this model is really conservative model. It tends to classify the loan as 0, which is default. It is still usable in our opinion for the lending corporate since it is very conservative, so it can prevent the potential losses.
We noticed that our dataset has quite a significant imbalance between the two classes, which may be a factor that has negatively influenced our model. For decision tree and random forest, we'll perform stratified k-fold to determine new set of parameters and compare their performance with our current ones. For Gaussian naive Bayes, we'll also use a stratified train test split to solve this problem. And that's all. Thank you.